Hello everyone, welcome to the May 2022 newsletter. Today we are announcing our G-Scale products. We have two new products on top of that. We have so much going on, it's crazy. There's a video following here that gets, we're going to go outside to the house and we're going to show you our G-Scale. It's been under development for more than a year. A lot of things to do with designing and working with 3D printing and making it work outside, as well as the sensor, so that it can deal with the outside climate. And in fact, the other day we tested it facing directly into the sun, and it works great, which is just amazing. So that's kind of fun. The second thing that we have going on is also on the layout. This is a DCC Relay Controller. So inside of this controller is a double throw, double pole relay switch, and you can turn it on and off with your DCC system. Super simple. I think there are other ways to do this with relays and DCC, but it's not easy. So we just put it all in one case, and there you go. That's shipping this week, shipping now. So that's available. And the other thing is working towards some automation where we can have trains start and stop and switches change without computer control, just based on sensing where the trains are and making sure they don't run into each other. We're introducing the smart switch. There's lots of different features of the smart switch. Too much to do in the intro, but there is a full-length video talking about it. It turns the turnouts, all different size from N to G scale. It has a way to connect switches of any kind. So if you wanted to have, for your coil switches, replace those slide and push things with push buttons or toggle switch, not necessarily spring-loaded, the smart switch can do that. Nothing to do with DCC, but if you have DCC and you want push buttons out in the layout to work in parallel, the smart switch will allow you to do that. And then kind of the last and the big ticket items is that there's a signal. The smart switch knows which position the turnout is in. It remembers that when you turn the power off, but it also has a signal out which will drive our dwarf controllers and so forth. So one way to do that was an earlier product called a coil sensor, and it simply detected which way the coil was directed. This you can actually control and turn the switches, which means you can also connect our precision sensors to this, which will cause the turnout to turn in favor of the train or not, depending on what's going on. And so when we get into the details of the smart switch later in the video, you'll see how that works. So all sorts of great stuff. We support all the different kind of switches, motorized, coil-based, all the scales. Pretty cool little nice mounting system. It's friction-based, and it will stay in there, and so we really try to make everything simple. There's some other updates in the written newsletter that's in the email version of this. If you're not on our newsletter list, please join the newsletter. There's usually a pop-up every couple of days or so that'll allow you to subscribe to the newsletter. That's a great way. That's where we announce all the new products and all the new information. There's some bits in there about the sound module, and we've just been hearing great things from folks about our products and giving us some new ideas, and so we appreciate that. And so let's dig right into the G-Scale, the DCC Relay Controller, and the Smart Switch. That's a lot going on for the month of May. Thank you. Hello everyone, welcome back. This is Jim Lewis at Model Train Technology. Well, today's the day. We finally got there. We're announcing our G-Scale signaling system. We have other G-Scale products on the way, but we wanted to start with this. We're so jazzed. We moved over to our house because we have what's called a Florida room in Orlando, Florida. It's a big concrete slab with a screen over it, and we have a G-Scale layout running around that. Here's our Union Pacific engine. It's battery powered. We run it on that. We're going to show you that in just a second. One of the challenges, of course, outside is the sensor, and we pioneered the notion of the precision sensor, and the one that we use for N scale and HO is about 5.5 inches, and that'd be pretty close. That would work, but we wanted to have something more robust and allow more flexibility. So we worked very hard. It took us a year actually to work on the sensor and all of the electronics. I'll show you how they're configured. One runs on battery, and the other one can be powered by 12 volts DC. But anyway, let's show the signals in action, and then we'll come back and I'll show you how all of the configurations are set up.
Block signals clear.
So let's show you how all of the signaling is set up. You may notice that I have these big rubber blocks here, and these are actually, I found these on Amazon. They're jeweler's pads, and they're used for hammering different jewelry pieces. For our setup, when we have a big slab and we just want to lay these down, This worked out great. It's heavy relative to its size. We drill holes in and we provide these little rubber, these are 3D printed pads. Rubber on the hot concrete would start to color and fuse with the concrete. So these resin pads keep it off the cement. Even though it's painted, it does leave a mark. Without that, without the pads. But with the pads, there's no problem. We pioneered, this is our O-scale sensor. You may have seen this before. Here's the sensor in the back, and it comes with an electrical case. This sensor, we've upgraded this sensor to the outdoor scale, so it has about a 1 meter range. Now, low to the ground, remember that this sensor beam that goes out spreads out as it goes out. So we need a little height here, but you can use these small sensors up close if you want to connect them. So there's a sensor in the two configurations here. This is the powered one. In other words, it requires 12 volts to come in to run it, and you can just slide this off and you can see the electronics. So what we've done is we've combined the signal controller with our sensor onto one board. So there's actually a sensor mounted on the back side of the board, and there's a little hole in the case so that when this slides down over it, the beam can see the train. On the inside, you can wire up a variety of block signals. So right now we have two. We have the 7 light signal, and then we have the 3 light signal. And these functionally are the same as what you've seen in the N-scale and HO. If you want a full description, go to our video. There's a link at the bottom of this video to see our signaling video that we did about a year ago. It goes into great depth of that, but we'll talk about most of that here today. On the board here, there are 3 trim pots, one to adjust the speed of going through the stages, so you can see the light will change. Let's see if we can trigger that off. There we go. And it'll go through from green to red to yellow and back, so you can speed up or slow that down. The second trim pot is for the timeout of the sensor. That is, after the train has passed the sensor, how long does it stay on until it starts the color changing sequence. And the last sensor, the last adjustment you can make is the distance. And we have played around with this quite a bit, and we think that up to about 18 to 20 inches is a pretty good distance before you start hitting the sensor starts seeing the track itself as opposed to the engine on the track. You can solve that by just raising the sensor a little bit, and that cone of vision will raise up. But that's a pretty good distance. I would think most of our situations, we did it inside of a foot, and it worked great. What also is amazing, it works at night in any light condition. And the other day, we pointed it, the sun sets behind me, we pointed this directly into the sun as it was setting, and it worked great. It's just amazing. So we're pretty excited about that, that setup. So now, this, as I said, this is the one that's powered. I actually am powering it off a battery. And this is the inside of what this looks like. We'll take this off in a second. But in this case, we designed the battery pack around a lithium polymer battery. This is called a short. And this one has 5,000 milliamp hours. So figure that it uses 50 amps per hour for running it. So you've got, I don't know, 10, 12 hours of use with the lights fully on. This does have an automatic shutout, which you can turn on and disable or enable. In other words, after an hour, the lights will go off. In other words, nothing passed in front of the sensor, the lights will go off to save a little current. So if the trains are not going by frequently, that might be a way to go. As soon as a train goes by the sensor, the lights come back on automatically, and it will stay on for an hour and follow those aspects. So anyway, here's the battery. You can buy them. We're not going to sell these online because we'd end up shipping LiPo, this is what they're called, lithium polymer batteries. And so what we're going to do is have a link to the Amazon site where you can buy both the batteries in packs of 2 or singles, as well as the charger. There's a variety of chargers. We tested them. It's really simple. There's a fast charge mode, which will charge it in less than half an hour, and then an overnight mode. Pretty cool battery. It's a really great one. So the way this works is we built the circuit board to slide into the banana plugs on the battery. So these come, this is the way the board comes, and you just take this, and in fact, this board right here, I have plugged into these lights. So there's a power outlet. So the battery that I have here was powering both this board and this board. And the way I do it is just plug it in. I'm going to put the wire in between the wires just for keep it clean. Turn the battery on. The sensor will blink 4 times very rapidly to say it's up and running and ready to go. And then this slides into this sleeve that we made. And the sleeve can either fit the bumpers for just putting out on the layout like that, or you can remove the bumpers. They just pop off. And if you want to super glue them on or glue them, whatever. But then also this provides a nailing hole if you want to put it into the ground. And so what we've used is, not here because we've got concrete, but in our test out in the other part of the yard, we used aluminum nails and just pushed them into the ground, and that kept it sturdy. So that's the sensor. Now, on this one, we're just using this for power right now. So let's see, we back up and running? Yep, great. Okay. So this is the 3-light sensor. You can run it with the red lights, the center light off for red, or with the center light always on. Also with the HO and N scale, customers asked us for different lighting patterns. So one customer has red on the sides, no center light. He asked us to make, so we have a version with no center light, 2 reds, 2 yellows, and 2 greens. That's fine. We're happy to do that. We will sell the mounting block and the magnets that come with it. Remember, we have the magnet system, so you can easily knock this over and not break the unit. This is an aluminum pole here and 3D printed. We included in the kit is a template for locating the hole. If you wanted to drill this or put the magnet somewhere else, it shows you where to put the magnets. There's a little red dot on each magnet to show you the orientation. The red dot is up. The signal itself already comes with the magnets installed, and there you go. So that's it. Now, one of the things that, so let's talk about this one. This one's pretty cool. I just mounted on a single block so that I could just take this, literally put this out on the yard. It's got the battery in it, just like the other one. Okay. And this one also, so anyone with a battery, I can take this cable and plug it in here. So this battery could run several of these signals. Probably 3 or 4 would be okay. And then you probably want a second battery. The other thing that all of these have is a little jumper here. And we have these brass strips. We're using our floating brass here. And this box, which comes with it, and the box goes over the top, slides onto those brackets, and there's the little light on the outside that shows you that the power is on. So it's pretty prototypical, and of course this goes on and off. So this is just completely stand-free, and we can trigger the lights. Let's see how far I gotta go out. Yep, there we go. And this box can be mounted separately like this, or it can be mounted on a single block and you just take it out. There's a little on-off switch right here, so I can just shut down the whole thing, or I can take the whole battery assembly out, unplug it, replace the battery. So that's pretty cool. The other thing that we included in this, because we were in the last stages of development, for N and HO, our precision sensors now have a push button on the back instead of the dip switches. And one of the things that we added was auto ranging. And so while I can take the provided screwdriver and adjust the distance where I want the detection range to be, I can also use the auto sensing. And the way that works is I just put it into auto sensing mode, put a train car out where I'm going to detect it, This will go into a flashing mode, take a picture, essentially a digital sensing of where the train is, and then that will be the range. And for G-scale, while we don't have varmint running around inside the cage here, I could imagine a squirrel or a cat running, going between the sensor and here, or on the other side of the track for that matter. They might not walk on the track, I don't know. But if you put it into the zone mode, instead of detecting the entire range from the sensor all the way to the train, it will only detect a 50 millimeter area, which is basically the rail distance. So if a cat walked in front of the sensor, it would not trip. Likewise on the other side. So that's very cool. And setting it, like I said, is pretty simple, either with the screwdriver here or by pushing the button. Again, all of the modes in terms of the aspects, there's these, you can get 2 aspects. So this is a 3-light system, so we have 3 lights. You can have ones that fade from mode to mode. There's a yellow flashing, there's combinations here. And so that's all included in the kit. And lastly, as I mentioned before, we have something called latching in our NNHO setup. And what that is after the train passes, if it's in the next block, you can run a wire from one signal to the other signal, and this will not turn green until the block ahead is clear. That's what we call latching. So that's available in all this. You can have forward latching, and you can have that latching daisy chain all the way around your layout. So that's the introduction of the G-scale. We do have several more products. So if you can anticipate what we have in NNHO, for example, the dwarf signals, that will be available this summer in G-scale. Contact us if you want more information there. And so this completes our range going from N-scale all the way to G-scale in all the lighting and signaling systems. Some of the next projects we have underway are for movement, and so you can anticipate what kind of things we have there. Oh, I should mention also that like the signal control, there's an output trigger on this. And so that will trigger our sound module. So if you wanted to have some announcement or bells or other sounds, barnyard sounds, as the train goes by one of the signals, you can just hook up one of our sound modules to that. You'd have to protect it. The sound module is not waterproof. We've had these outside quite a bit in the burning sun of Florida, and we'll continue to test them, but they've been very rugged and durable. We have kind of a weeping system so that any moisture that gets in weeps out the outside of the box here as well as over here. The sensor's been very durable. We haven't had any trouble with that, rain blowing and so forth. So we're ready to go, and look forward to your questions. Thanks for watching, and enjoy the Hello everyone, my name is Jim Lewis. I'm the founder of Model Train Technology in Orlando, Florida, and today we are announcing a new product. It's an extension of our signal controller line. You may have seen these before. This is a DCC relay, and the way this works is you use your DCC system, you activate a switch command, and you get a double pole, double throw switch to control just about anything on your layout that isn't already DCC controlled. So you can run lights off of this, you can run motors. It's up to 1 amp capacity on the contacts, and it's powered separately from your DCC system. So the only thing that DCC does is power the electronics for the circuit and the relay, and it's a micro relay. It uses 23 milliamps when it's on and barely anything when it's off. So hardly any impact on your DCC system, unless you have dozens of these scattered around the layout, or probably 50, you might begin to see an impact. That would be great. Let me show you how it works. I have a Zephyr, Digitrax Zephyr in front of me. I also connected up a hand unit just to show you how easy it is. And we're going to use this plug. It does come with wired. This is 3 feet long, so you just plug into here and connect it up to your A/B rails on your DCC system. Once I finish with this introduction, there is a brief, about 10-minute discussion about switching, and I just thought it would be a good opportunity to talk about double pole, double throw switches and how to wire them up, because that's what you get with your DCC controller. So that's in just a minute. We're going to just use these DuPont plugs to plug in the power. And let me see, that might be the hardest task. Okay, there we go. And I'm going to put the power on for DCC. And there we go. Now you will see a blink there. We call it the heartbeat. And what it means is there's power to the unit, it's receiving a DCC signal, and the relay is off. So if I go to switch number 3 and I throw this, maybe, no, it's closed, pardon me, closed. Then the light goes on and that tells you that the relay is active. I'm going to push it the other way and it goes off, and it will show you the heartbeat. So if you're under the layout and you want to know is the relay on or not, the heartbeat shows you the circuit is live, but the relay is off, and you just push close. The address for this, that's always the next question, is any valid DCC switch address, or an accessory address is what they call it. So from 1 to 2044. And it's really a breeze to program. So we'll turn it off. I'm going to hold this. Actually, let me hold it up so you can see it better. I'm going to press and hold the select button. And after about 8 to 10 seconds, the light will come back on, and you release the button, and you'll notice that it's flashing. So the way to program the new address is to hit switch, and I'm going to use 456, and either thrown or close activates it. It blinks, and now that's the address for this device. It's that simple, and you just connect up the switches there. So that's available, shipping next week, and just go to our website and visit the store. It'll be called the DCC Relay Controller, and that's from Model Train Technology. So let's take a look at the intro and the instructions and explanation on the relay stuff. Thanks very much. This is a brief tutorial on switching, including double pole, double throw relays, and the reason we're doing this is so that you can be oriented to successfully use our DCC double pole, double throw relay controller. So this is a really simple on-off switch called a single pole, single throw switch. If we add a second option or connection to this diagram, we get what's called a single pole double throw. I mean, double means that there's two options, and the nomenclature used is normally closed and normally open. You might see these indicated as NC and NO, where space is limited on a diagram or on a part. If you add a coil to this, the coil is electrically independent of the switch itself, and that's one of the advantages of this. So you can activate the coil, and the coil will make the pole switch between the two normally open or normally closed configurations. So that's a basic single pole double throw switch with a coil. So that would be called a coil relay. And what you might want to do with this single pole double throw switch is simply switch between two indicator lights. In this example, we have a simple 12-volt supply. I did not include the resistor. Anytime you use LEDs, you should have a resistor in line. And this would just simply turn on the red and the green light alternately. Now, when you put two of these single pole double throw switches together, of course, you get a double pole double throw switch. And these two circuits, the one above the yellow dotted line and below, are electrically isolated. That is, unless you purposely connect, for example, the commons together or some of the other side. They're mechanically connected, so they will switch at the same time with the activation of the coil, but they're electrically isolated. And there are advantages of that. So you might have the indicator lights work on the lower half of the switch, and you might have a motor or a switch of some kind, other kind of activity going on, and they can be independently powered, so they can have different voltages. So that's one of the real nice advantages of having a double pole double throw switch. And the DCC controller, relay controller that we are introducing here, has a double pole, double throw switch inside. One of the common things to use a double pole, double throw switch is to reverse the polarity. So in this case, we're using the two commons as the output rather than the input. And the yellow block there indicates this is more of the way the physical switch works. And when you switch the switch, the yellow connections go in parallel and reverse the voltage since the two power supplies are crossed between the outputs. So if you look at the bottom, you can see how they're connected, and then go to the top and switch. So you might use this to control a tortoise machine where the two motor inputs, the way you activate the motor is just to reverse the voltage. So this is how a double pole, double throw switch would work in that configuration. You might have this mechanical switch on your panel, and that's how you would change the tortoise switch. So here's the signal controller, the DCC relay inside. It has a double pole, double throw switch, and here are the outputs. So they're, again, electrically isolated, but mechanically connected. And you can just follow this diagram as you're wiring up your outlet. The hole in the middle on the bottom is the blue LED indicator. We use that to let you know what's going on. And then there's a push button, and the push button allows you to set the controller address. Anything that's a DCC valid switch address from 1 to 2044. I hope that was helpful, and thank you for watching. Hello, model railroaders. Let's talk about the Smart Switch from Model Train Technology. This is a new product, and it combines a number of very clever features. We're looking to do some animation without using the computer. So one of the scenarios we're thinking about is a train coming along and going into a siding and stopping when it hits a sensor, and then changing the switch behind it and letting a train come through which hits another sensor to make sure that the switch ahead of it is aligned straight, passing through, hitting another sensor, and then once it gets past that third sensor, releasing the train on the siding, turning the switch and letting it go. So some animation with just some relays and the precision sensor and the Smart Switch. The Smart Switch, the key part to turn the switch based on input from the sensor. So that's kind of where we started. But once we got going with that, we realized that we could set it up so that you could add any kind of switch to turn your turnouts. So on the fascia of your layout, some of you have toggle switches, a couple of buttons. Some of you are using those Atlas switches and would like to replace them. So for any coil-based or motorized turnout, you can use the Smart Switch and use any kind of switch. So the first version would be just pushing one button, pushing it again will turn the turnout from thrown to close and back again. Another version that you might decide to do is two buttons. One is for closed and one is for thrown. You can use your existing spring-centered toggle switch if you like, but you can also use a regular toggle switch, and that's one of the things that will probably save some money on switches, because right now you probably have to have a spring-loaded switch to momentarily connect the coil to turn the switch. Well, with the Smart Switch, you can just put a regular throttle, and once it knows the switch has been turned, it fires the coil once and stops and waits for a change of the switch position to do it again. So you can switch it back, it'll detect that movement and turn the coil. It has those same inputs from the switches, also will take the sensor input from the precision sensor, our precision sensor, and we'll show you in a couple of minutes how that works. We'll set up a little demo here, and we'll use our G-scale turnout to make that switch move. So the other thing is, a key part of this is that once we know which direction the switch is by this motion, we keep track of that, and we can send a signal out to our dwarf controller or to a relay to have some other activity. It can trigger on sound, lots of different things that you can do with that. You can adjust the speed of the motor, you can adjust the timing on how long the coil is set, and just with the push of a button you can make the adjustments between single switch and double switch. So pretty cool, and we made this little mount. It's pretty straightforward. You can mount this just about anywhere. There's some friction tabs inside, so once you push it all the way in, it doesn't come out. All right, so it's pretty rugged in that way, but with just a pull, it'll come out, and you can disconnect it and move it to your bench. All right. So what we've got here, I'm going to have you move in closer and aim down on the bench so you can see a little bit better what we're doing, and then we'll go through the demo. As I was making the intro, I realized that I missed mentioning one of the other features. There's so many in this smart switch, but this will run off of DCC as well. So you can control it, you can have DCC power it and have the input to DCC. So you can control it as a switch, simultaneous with any kind of switches you have on your layout. So you can switch it by DCC or with the switch or by the sensors. All of those are possible all at the same time. And I'll demonstrate the DCC here in a minute. All right, so what I have here in the setup is I'm simply going to use one of our power modules. It's 12 volt DC. All of the switches we've played with, from all the way from N scale Kato to the G scale, run very nicely off of 12 volts DC. And that's what we recommend you do, because from a signaling standpoint and so forth, it just makes things easier for you. I know a lot of layouts have AC. It's super simple to just switch over to DC. Pretty much you don't have to change any of your switch wiring. Also, I'm using these little what are called breadboards simply to make plugging things in and so forth easy, and to show you some different configurations. All right, so let's move that out of the way. So right now I'm going to turn the power on the power module, and you'll notice that I have a green light. It has a green and red light. The blue light is power is on, and over here I just have a simple Atlas switch with the 3 wires. And on this side are the 3 wires for driving a coil switch. In the case of, so there's a center common, so we'll put that in the middle here. And then there's basically a left and a right, and we'll just connect them up. So there's nothing magical about that, just an easy way to connect those across. All right, now on here I just have a common and some push buttons. And so if I push the button, you can see the switch. I'm using 2 switch mode, and so you can see the turnout moving rather nicely, and you also see the red and green lights alternating. Okay, so now when that's alternating red and green, the signal out line, which will go to the dwarf controller or block signal or relay, you don't see it, but that you just hook up the yellow wire there, and you're all set to go. All right, so right now I have 3 switches. I'm just using the first 2 for a left and right or thrown and closed, and you can see how that works. Pretty simple. All right, now what I'm going to do is I'm going to configure this for single push button. So when I do that, just pushing one button will have this alternating from thrown to closed. So if you just wanted to have one push button on your fascia, on your layout, that's the way to do it. So the way to do that is 1, 2, 3. This will blink, and now we're in single button mode. Okay, and this one doesn't do anything because we're in single button mode. Okay, so pretty straightforward. I have a Digitrack Zephyr here. I think you can see that. and I'm just going to connect this up. I've already programmed this to address 3. Well, let's do it again so you can see how simple that is. So to program this, to put it into address programming mode, I'm going to hit push the button and just hold it for about 10 seconds, and the light will come back on, and then it will begin to flash. So now it's in programming mode, and all I have to do on my Zephyr is choose a switch. I'm going to choose 3, and the light will blink. All right, and now we have DCC control, and we have push button control. And of course, we would still have the same signal going out. All right. So if you wanted to use a toggle switch so that you just flip it one way and flip it the other way to the turnout, what you would do is put it back into 2-button mode. And the way to do that is 1, 2. And now we have both switches operating. Okay. And we'll use that to demonstrate the sensors, which we'll set up here in just a second. All right, so now what I want to do, I'm going to change switches. I'm going to unplug the Atlas switch here. Just take these wires out. This is a LGB turnout, and what I'm going to do is just take the left and right wires. And this works just like the Kato. It's just a 2-wire system, and it just reverses the current on the coil. And my other wire fell out. I'm just going to put these in here. There we go. Let me put this back in here. Yeah, they're just loosely held for the time being. But now you can see I've got the same motion that I had before, and I can press my DCC system, and I could also use a sensor. So we'll do the sensor next, but you can see how easy that is. So all the way from G scale down through N scale in the Kato configuration, so it works great. One other thing that I want to show you is the motorized type of turnout, and the way to do that is to set this into motor mode, which is 5 presses. 1, 2, 3, 4, 5. Okay, and we'll hook this up. All right, so you can see the motor moving. I don't know if you can or not. Let's do it here. All right, so that's with the push button. And of course, you can surmise that it will work with DCC. So that's the smart switch, just the basic setup. And now what I'm going to do is clean this up a little bit and bring the sensors in and show you how we would use the sensor. Okay, what I've done here is I've added 2 precision sensors. These are N-scale precision sensors. They have a common power going back to the power module, and then there's a signal wire coming off of each one of these. One of the signal wires goes to one of the switches, and the other signal wire goes to the second switch. You don't have to use the switches, but if you had the switches on your fascia, you had your DCC hooked up, and now you had the sensor, you could get a lot of different utility out of this. So the sensor by itself, one sensor will turn it closed and the other will turn it thrown. So I'll demonstrate that. I'll just put my hand in front here on this one, and now this one. Okay, so that's pretty straightforward. But if there was a train on the switch when another sensor was trying to turn it, that wouldn't be good. So the way this works is, let's say this first train comes along, and now the train wants to change the other direction. Until this one is clear, the switch won't change. But as soon as this is cleared, the turnout will go. And as you may know from the precision detector videos, all of these have a timeout. So the time between these 2 motions can be set. So let's say the train crosses here, and we don't want the switch to switch right away. Maybe we want it to switch 20 seconds or 30 seconds later, you can set the timeout to do that. Okay? So really cool. And if you connect this same signal wire up to our relay and with the relay adapter, now you can disable power on one section of the track. So as the train comes in, it disables the power for the other track, and then as soon as it's clear, it will re-energize that track and allow the turnout to switch. So this is just an introduction to give you an idea of the capability. It looks like it's a kind of complicated wiring. It really is not. I just have all these wires so I can plug things in. And like I said before, I can still turn it by this method or by the DCC system. So we'll have some other videos that get into more detail and actually have a set of trains going, stopping, and so forth. We can't do it on the bench here. But that's an introduction to the Model Train Technology Smart Switch. And this is available now. You can order online and at a store. And of course, the sensors are available. And thank you for watching.